Hello everyone, myself Yashwani and will explain the project of Ahmedabad Overbridge, which we took as a project for Studio 2, which is Construction Project Execution Monitoring and Control. Project is the public infrastructure brownfield project, and it is a 4-lane overbridge project with the cost of 79 crores, which is to be completed within the span of 30 months. The main objective includes the reduction in traffic congestion, accessibility and safety, since it lies in the very traffic congested area. For site layout planning, we identified the critics in the already planned site and their components, where we identify that there is no proper vehicular and pedestrian movement since only one gate is used for entry and exit, no proper area for steel stacking and scrap items. Therefore, we suggested a proposed layout where smooth movement of vehicles can be done by using separate entry and exit gates, dedicated area for steel stacking, further shade will be provided for bending and cutting yard. Casting yard is proposed within the boundaries since it was not there earlier. Later, we identified zero budget activities, which includes labor colony, ramp for batching plant and CCTV cameras. Also, we identified the waste on site, which includes the scrap waste, excavated soil waste which has not been dumped to the dedicated area, and inventory waste. For risk assessment, we identified risks in different categories like site layout, execution and quality related risks, where we prepared a threat matrix where the main threats identified includes the utility shifting, labor shortage and design drawing approval. Next topic is the pore planning. We limited the scope of 35 piers, that is the LHS stretch, for pore planning, where we have 4 different categories of piers A, B, C and D. Further, we bifurcated the pores as per elements, that is pile, pile cap, pier and pier cap. Here shown is the example of formwork set for pier category A, where we use different sets of formwork, that is set 2 for pier cap and set 1 for pier. These would be repeated as per the requirement. For formwork, we identified the direct cost of formwork by adding the cost of the labor through productivity calculation, cost of machinery and tools. Here shown is the direct cost of formwork for PU01, which is 3 lakh rupees. For reinforcement calculation, we calculated the steel requirements for pile, pile cap, pier and pier cap. Here shown is the reinforcement calculation for PU01 and its productivity calculation by separating the vertical members, that is pile and pier, and horizontal members, that is pile cap and pier cap, where 7.21 is the man days per metric ton for vertical members and 6.74 man days per metric ton for horizontal members. For direct cost of steel for PU01, we added the cost of labor and machinery cost, which comes around 37.98 lakhs. Further, we calculated the area for steel yard during the peak reinforcement requirement, which turns around to be 2,149 square meters of the area for 31 metric ton of steel, as per our calculation from the MS schedule. Similarly, for concrete, we calculated the concrete requirement for pile, pile cap, pier and pier cap, same as steel. Productivity is calculated for vertical members, which is 7.10 man days per cubic meter, and horizontal members, which is 7.9 man days per cubic meter for PU01. Direct cost of formwork include total concreting cost plus labor cost. Later, we compared the RMC and batching plant cost. For batching plant, cost owned for per cubic meter for M40 grade of the concrete is around 4,911 rupees, whereas it is 6,200 rupees for RMC. Hence, for the project like Overbridge, owing a batching plant would be more cost effective compared to RMC, especially during the peak concrete requirement. For tools of quality, we prepared a control chart for M40 grade of concrete to identify the compressive strength. We took the results of 50 samples for the same, where the R chart shows that only one sample is above the upper limit and the rest is within the limit. Similarly, for the X chart, all the samples are within the limits. Next, we prepared histogram chart for slump test for M40 grade of concrete, where we took 200 samples for the same. Hence, the highest occurrences fall under the category and the range of 140 to 150 mm, which is having the highest workability as per the IS codes. Next, we identified non-conformity of honeycombing in girder and prepared the Ishikawa diagram for identifying the root cause. Here is the major root causes, which includes the substandard workmanship, inconsistent concrete mix due to batching plant error, inadequate vibration, leaking in formwork due to improper sealing and lack of shade. Later, we provided the corrective measures, which include the removal of the affected concrete area, and after applying the bonding agent and application of the mortar, and later the curing is done, and the final NDT testing is to be done to identify the strength. The conclusion include for the site planning is all of the site components have been identified, including the labor mess, labor colony, and restroom arrangements. Major risks related with pre-construction, execution, and post-construction are identified, and later the zero budget activities and their importance are studied. For pole planning, for each of the elements, pile cap, pier and pier cap, reinforcement bar calculation, concrete consumption calculation, and formwork needs are calculated, and the productivity and direct cost of the concrete, reinforcement, and formwork for PU01 are determined, as well as the peak requirement are identified for the PU01. Control charts such as X and R charts are created for tools of qualities for the cube testing for 7 days as well as 28 days compressive strength. Using the result of the slump cone test, we created histogram charts to demonstrate the frequency of the results. The Ishikawa diagram was created for a non-conformity of honeycombing and girder. Causes were identified and preventive and control measures were proposed. Thank you.